In photography, reflections can be a problem. We might want to eliminate reflections when we're photographing products, artwork, or landscapes. Direct reflections can be controlled to some extent using families of angles, and I've covered that in another video. If we can't completely eliminate them, then there is a last resort we can turn to. Like most things in photography, we can solve problems by buying another piece of equipment. This is a circular polarizing filter, or a CPL. Why is it called a circular polarizing filter? Because it's round, unlike the square types. I'm kidding with you. I'm completely kidding with you. It's got nothing to do with its physical shape at all. It's actually because of how it transforms light waves passing through the two different elements that are in it. And we'll dig deeper into that later on. Have you ever played with one of these and thought that it doesn't do much? Well, it's not magical, but it can completely transform a photograph. And to do that, we need to understand what polarized light is and how it works in order to control it. A light wave has a sinuous form as it moves from point A to point B. Looking at it head on, we can see that it's got an orientation. Most of the time, there are many waves and they're oscillating in lots of different orientations. It's like the spokes of a wheel from the central hub. This sheet is a linear polarizing filter. Linear polarization means that only spokes in one orientation, the one parallel to the long side of this sheet, can pass through. The rest of the spokes get blocked. When I put this filter in front of the lens, the exposure reads 1.5 stops lower. More than half the light is gone, and that's because of all of those spokes that we filtered out. If we have a second linear polarizer at 90 degrees to the first, we've just blocked out the only light that we had left, and it goes completely dark. The filter isn't the only way to get polarized light. We can also receive polarized light when it bounces off certain materials. It causes a glare, and that's why you only need a single polarizing filter to eliminate the reflection from the surface of the water. The light was still polarized twice, once at the water's surface and then again through the linear polarizer. When the reflection's gone, you know that the angles of polarization are at 90 degrees from each other. Notice that the light source is not polarized. It only becomes polarized after it bounces off the water, or if it passes directly through the polarizing filter. Without a second filter, it's not eliminated. We need two polarizing events so that we can eliminate polarized reflections. Either two polarizing filters, or a polarized source and a single filter over the lens. It's not always easy to tell which objects will produce a polarized reflection and which ones won't. It can even depend on the angle that you observe it from and what sort of light is shining on it. The definitive test is to simply use a polarizing filter on your object, and if the glare dims when you rotate it, then you know it's creating or reflecting polarized light. And you don't need a polarizing sheet like this. Your circular polarizing filter is effectively the same thing. The linear polarizer is the bit at the front that spins. So just give it a go. Try looking at glass, ceramics, dull wood, shiny paper, plastics. See what works and what doesn't. Insulators like glass, polished wood and plastic can often give polarized reflections. The angle of observation matters and the light source matters too. Why would a shiny metal ruler not react to the polarizer indoors at night, but it does react outdoors during the day? Have a think and I'll give you the answer in a minute. Eliminating glare leaves us only with diffuse reflections from an object, and that's the type of reflection that allows us to see an object from anywhere in the room at any angle. The darker the object, the more glare we notice because they produce fewer diffuse reflections than a light object. The strength of the glare might be the same, but it overpowers the diffuse reflections on the dark object, so we notice it more than in the light object. We can reduce glare where it exists, but sometimes it can't be totally eliminated. We might still have a component of non-polarized direct reflections. But we can improve this situation if we get sneaky. This is a non-polarized bulb and it's shining on some artwork. Rotating the polarizer helps, but there's some glare that still exists. And that's because there's a proportion of non-polarized direct reflections mixed in with the polarized direct reflections. We use a polarizer on the lens to treat the light going into the camera. But here's the trick. We can also use a polarizer on the light source. And now we've converted a non-polarized direct reflection into a polarized direct reflection. By getting rid of the non-polarized component, all of the glare is polarized and we can completely block it with the filter on the lens. All that remains are the diffuse reflections that we need. You can polarize an unpolarized source, but you might even have a light source that is already polarized. Actually, you definitely have one. Put a filter in front of your computer monitor or phone and you know that it's already polarized because it gets completely blocked out by a single filter. Remember the metal ruler? It doesn't give a polarized reflection from an unpolarized light bulb like the water did. Conductive metals usually don't polarize light. That's why the filter didn't reduce the glare. It's an unpolarized direct reflection. But outdoors, the open sky acts like a polarized light source. It's really a secondary source because it creates a polarized reflection from the non-polarized sunlight. The ruler simply bounces the polarized skylight into our lens. It was the incident light, not the object, that caused the polarization. This works with the sun behind you. Move so that the sun's in front of you and you're dealing with the non-polarized direct reflection of the sun rather than the polarized light bounced off the sky. This loose polarizing sheet is a lot of fun, but you're more likely to buy a filter that attaches to your lens. And it turns out linear polarizing lens filters are quite hard to find. They exist, but circular polarizers are way more common. Why is that? A linear polarizer on its own can cause problems for exposure metering and phase detect autofocus. Depending on the way that your camera works, the electronics or the internal optics might contain polarizing elements and they won't play nicely when receiving linearly polarized light at the wrong angle. And that's where the circular polarizer comes in. This filter has two important parts. First, there's the rotating element on the front. That's the linear polarizer that we know and love. But it's also got a second fixed element at the back. This is a quarter wave plate. Don't panic. All it does is take filtered linearly polarized light and gives the resultant light waves a spin. That's the circular part. The wave plate slows light down in one orientation more than the other. The best visual I found was this video on a channel called Rough, and it starts by showing the resultant wave of light polarized in a linear polarizer. Then it shows the effect of the quarter wave plate, which offsets orthogonal waves by a quarter of the light's wavelength. The resultant wave, shown in green, in effect rotates in a circular pattern as it travels. I'll link the video below, it's well worth a watch. Light waves are converted from a linear to a spiraling circular polarization, so your camera's electronics can receive waves in many orientations and can deal with it better. There are lots of legacy lens filters that do many different things. Some alter the color temperature, some are neutral density filters, and they can be replaced to a limit with digital tools. But software cannot replace the physical circular polarizing filter. It addresses the problem of glare at the time of capture. It's not a slam dunk solution, but it's a powerful tool to master the light in your images.